Okay, our last little unit of the year, we have a short little 3-day unit on exponential functions. And so right off the bat, we'll just take a look at several different functions that we have covered throughout the year. So let's do a little matching game. Which one is the first one? What type of function would this first one be here? Y equals x plus 1. Linear, good. What about this next one here? This next one is, well, this kind of gives it away, that part. Cubic, right? This next one right here would be the parent of an absolute value, right? Absolute value. Okay, those look like V's. This next one is like half of a tipped over parabola, and because you can't have a negative inside the radical, that's why it doesn't go down in negative land, right? So it doesn't go down there. So it's not down there. So it's going to be a radical. So that one's a radical function. All right, then the next one is going to be this whole unit that we're covering right now. This is exponential. So that's kind of a new one. And then this last one here, of course, is quadratic to the second power. We've covered all this stuff. This is a 3 little day unit all on exponentials. So we're going to be working on stuff like that right there. Okay. All right, so things that we're going to do today, we're going to introduce you to exponentials. We'll be determining if something is exponential, looking at tables of values, and we'll be writing equations and graphing a little bit. So on here I don't have, I'm missing one. We're also going to be graphing. So sketching graphs. All right, let's keep moving along. Here's an example of an exponential function. This one's kind of I picked an easy one to start here, easy to understand because the base is 2. It's 2 to the x. So what does the function f of x equals 2 to the x look like? Well, let's kind of look at some of the values here when we put different values in for x. So if we have a table down here, one of the kind of key values is when the exponent stuff is equal to 0. And so if it's 2 to the x, then what would make x equal 0? 0. So when I put in like 2 to the 0 power, what do I get? Anything to the 0 power is 1. So this right here is kind of a key value in that your y-intercept, where it crosses the y-axis, is going to be here at 1, right? And then anything after that, it starts getting bigger and bigger and bigger. If I take 2 to the first power, what do I get? 2. If I take 2 to the second power, I get 4. And if I take 2 to the third, I get 8, and so on and so forth. It just keeps going up and up and up and up and up. You've maybe heard someone say, whoa, those two things are growing exponentially. Usually what people mean is that they're not actually growing like with an exponential function that you could plot the points on, but they're saying that they're growing really rapidly. So some people will use that term not very specifically. They'll use it kind of loosely to say that something's growing really fast. Because think about exponential growth is once it starts increasing, it goes up and rockets really fast. It's like a skyrocket. If you go backwards, something neat kind of happens as well. So let's just say we go backwards into negative land. If I take 2 to the negative 1, I get, flip it, I get 1/2. If I take 2 to the negative 2, I get 1/4. If I take 2 to the negative 3, I get 1/8. And it just gets really, really, really small. And these values, as we keep going this way, are basically going to what number, but they're not really ever going to be like getting to that number. What's that? 0. Good. So they're not really getting to, they're not really going to ever be 0, but they're getting closer and closer and closer to 0. Okay, that is tied to this concept right here. And there's this, you see this green line in here, this horizontal line. That's the line y equals 0. It goes forever. It's called an asymptote. What's it called? Asymptote. Watch your language. It's an asymptote. Careful. An asymptote is like an imaginary line where a graph is going towards, but it's never, ever going to touch the line, but it gets really, really close to the line, as close as you could possibly get without ever being that value. Okay, it'll never get to 0. You can't take something to a power and have it ever totally diminish. It's going to be 1 over some big number, so it won't ever actually be 0. So that's an asymptote. There's a horizontal asymptote on this in this scenario. All right, some lingo here. If you have exponential growth, f of x equals a to the bx, this is just some generic exponential function. Okay, so if you have f of x equals a to the a times b to the x power, where the a is greater than 0, so the a is positive, and the b is greater than 1, then that's going to be growth. So if this value b is bigger than 1, it's going to be growing. All right, and if it grows, then y is going to be increasing as x increases. So y increases as x increases. On the other side of that, if we have exponential decay, that is where the b part is going to be between 0 and 1. So if it's like a number between 0 and 1, like a fraction, then that is going to be exponential decay. So y is going to be decreasing, or y decreases as x increases. Yeah, I mean, we usually follow time from like a left to right pattern. So she said x is always increasing. So like usually these are related to time. And so we usually think about it as like after 5 years, you know. If I made a little sketch of these, here, let's just make a little sketch of these while we're here. So exponential decay and exponential growth. Exponential growth, as y increases, x increases, is going to look something like this. So as you're going in the positive x direction, it's going in the positive y direction. It's increasing. So as x increases, y increases. And exponential decay is going to go like this. It's going to go as x increases, y is going to decrease. It's never going to get to 0 either. It's going to get close to 0. It's never going to totally be gone. It's never going to totally decay to be 0. All right, so those are 2 scenarios. Here's a reminder of y is a function of x, so y is going to be the dependent variable. So y depends on x. You know, y is sitting there going, I wonder what I'm going to be. Oh, x, will you figure out what you're going to be so that I know what I'm going to be? Poor y is always depending on what x is. X sitting there not knowing what it's going to be, and y's waiting for him. Yeah. All right, here's an example. Tell whether the function is growth or decay. How are we going to know if it's growth or decay? What is the value of the base? What's the b value? Since the b value here is 3/4, then this is going to be decaying, because you're going to take 3/4 times 3/4 a bunch of times. So if you take 3/4 times 3/4, you get 9/16, and 9/16 is actually less than 3/4. Okay, think about an easier value besides 3/4. What if it's 1/2? What's 1/2 times a half? A fourth. It's getting smaller. What's a half times a half times a half? 1/8. It's getting even smaller. So like if you have a number between 0 and 1, that's the base, then it's going to be decay. What's the y-intercept? The starting value. Okay, well, if I put a 0 in for x, because that's where the y-intercept is, a 0 in for x, that's going to be this one right here. Then I'm going to get what for y? Put 0 in for x, I get 3/4 to the 0 power, which is 1, and 10 times 1 is 10. Okay, so that's kind of a usually a key value, or we call that the starting value sometimes, or we also call it like the initial amount. Another way I like to refer to it as the initial amount. A lot of times you're working with like money or carbon, so it's like, oh, we got initial amount of carbon 14, and you're doing carbon dating and half-lives, stuff like that, or you're doing compound interest. How much did you invest? So let's just put that as, let's just say a 10 up here, okay? When x is 0, y is 10. Now this is decaying, so it's going to be going down as x increases. So as x gets bigger, this one's going to be getting smaller and smaller and smaller. Let's plot a couple points around it. 3/4 to the first power is 3/4. 3/4 times 10 is 7.5. 3/4 to the -1 is 4/3. 4/3 times 10 is 40/3, and 40/3 is 13 1/3. So if we just get a little idea from each side, if I go to the left, I get 13. I'm going to be like up here. If I go to the right, I get 7.5. I'm going to be like down here. So this one's going to go like something like this. Exponential decay. And this initial value we have is 0, 10. Feel free to pipe up if you have any thoughts or questions. Go ahead and stop me. It's fine. It's your job as a student, right? Yep. It can't be applied to every, depends on whatever the scenario is. What do you, hold on, I'm going to pause. All right, so we're going to go on to the next page. If anyone else, anything else? Okay. Next page, we'll just rattle off some 4 sketches, and we'll determine if they're growth or decay and what their initial value is and the base is. So g of x, is g of x going to be growth or decay? Does anybody disagree that it's growth? All right, good, because it is growth, and it is because the base value is more than 1. So the A, or the initial amount here, is going to be 100. So you're starting with 100, whatever it is, 100 whatevers. And they are going to be growing at a rate of 105% per whatever x is. Day, year, whatever. So B is going to be 1.05. And so we could make a little sketch of that. And my initial value when x is 0 is going to be up here at 100. So that's like 0, 100. And it's going to be growing. So when I go to the right one, that's going to be 105% of 100, which is going to be 105. And then 105% of 105. And then 105% of 105% of 105, whatever. And it just keeps going up and up and up. If I go backwards, this is going to be going down. So we're just making like a simple sketch here. So it's not going to be perfect. We're just showing the form of how the graph's going to go. So as you go to the right, it's going to keep going up and up and up. As you go to the left, it's going to get closer and closer to 0. But it's never ever going to get to 0. Remember, there's an asymptote there because you can't ever totally diminish 100 down to 0. Yep. Yeah, we're just finding 1 and then we're just sketching it. So 1 point, that initial point. Just a rough sketch. Okay, the next one is going to be growth or decay. This one's going to be decay because the B value is going to be between 0 and 1. So think about this as like, oh, it's 80% each time. You take 80%, right? So it's whatever you had after a year, it's 80% of that. Whatever you have after a year, it's 80% of that, and 80% of that, 80% of that, and it just keeps going down and down and down. So what's the initial value of this particular P of X? What's the initial amount? 30, and then the B value, it's like the decay factor would be 0.8 or 80%. So at 0 days or 0x, we're going to be at 30, right? So that's kind of the initial. And then as x increases and goes along to the right, 30 is going to be decreasing and decreasing. So this one's going to swoop in and look something like that, right? So every year it's going to be 80%. So like, what's 80% of 30? I like doing percents. 80% is 8 times 10%. So 10% of 30 is what? 10% is 3. So what's 8 threes? 24. So after 1 year, you're down to like, or whatever it is, 24, right? Now what's 80% of 24? This is fun. 2.4 times 8. 2.4 times 8, that's 16 plus 3.2, that's 19.2. So now we're down to 19.2. I'm just doing that for fun. Percentages are really actually not too bad. Just take 10% and then multiply it by whatever you need. So if you need 80%, you take 8 10%. 10% is always easy because you move the decimal one to the left. All right, last two. These ones are a little funky because they have a negative initial amount. So here we have a negative initial amount. So is this growth or decay? That's decay, but like I said, it's going to be a little weird because the initial amount is negative. A is going to be a negative 3. The base is going to be 0.76. So now when we sketch this graph, actually I'm going to sketch that a little differently. I'm going to go like this. Give myself a little more room down there. What do we get for an initial amount? Negative 3. So now we're down here. We're at like negative 3 down here. Okay. If I am traveling in the positive x direction and I make x 1, what is going to be g of x when x is 1? Well, that's negative 3 times 0.76 to the 1. So what is 76% of negative 3? Well, it's going to be like negative 2 something probably, isn't it? It's going to be a smaller negative, which is actually a bigger number. So I'll just calculate this here first. Negative 3 times 0.76 is 2.28. So negative 2.28. So what's happening now is this is going to be going like this. And then the next one's going to be even getting bigger and bigger, but it's actually a smaller negative, right? But it's a bigger number. And this one's going to get closer and closer to 0 from that direction, but it's never going to be there. If I go backwards, it's going to get to be a bigger negative, so it's going to end up kind of going like, it's going to have this form like this. Which kind of makes sense if I think about my transformations rules, because there's a negative right here. And is that negative with the x or with the y? Is it going to the power with the x? No, it's not. It's actually with the y stuff. So then it's like we had an exponential decay, but it was flipped over the x-axis, right? It's like a reflection. Know what I mean? If I take this value here and I flip it up and down, it's going to be like that one, kind of. So it's also, you can think of it as like a reflection. Alrighty then. Last one here, we're starting again from negative land. So my initial amount, my A value is negative 5. My B is going to be 2, which means I'm going to have growth. And so when I have growth, I'm going to make a little sketch, but I'm going to start down from negative land. So I'm going to be down here, negative 5. What's going to happen with this puppy? It's going to grow, but when it grows, I'm going to get a bigger when it grows, I'm going to get a bigger negative. And so actually it's going to grow, but it's going to grow in the other direction, right? God dang it. My smartboard's off a little bit. Oh my gosh, it's totally. So now it's going to end up going. Crime in Italy. It's going to end up going down. So it ends up going like this. When I put a 1 in, I'm going to get negative 5 times 2 to the 1, which is negative 10. So I'm going to be like down here. So this one's going to go like this. Which hopefully makes sense, because if it was exponential growth anyways, exponential growth would have looked like that, and it's just kind of reflected over the x, right? So this would be like negative or positive exponential growth, but if the base or initial amount, excuse me, is negative, then it flips it upside down. All right, phew, puftas. Any questions on that so far? Getting closer, nobody's sleeping yet. You're good? Okay. All right, let's take a look at writing an equation from a table of values. Oh, this is linear. This is throwing a little curveball in, but it's not curved, it's linear. So it's a fastball. Good one. So, oh, y equals mx plus b, she said. Great, nice job. Good recall on that stuff you've learned. Y equals mx plus b is what you need. And so you need to know the slope and you need to know the y-intercept. Where does the y-intercept come from? When x is 0. So when x is 0, that's the y-intercept. In this case, it's going to be negative 4. All right, now what's the slope going to be? We need to know the slope. All right, well, the slope is going to, you can either take 2 points and go y2 minus y1 over x2 minus x1, or you can look at this one, because this one goes up by 1 each time for the x. So each x is increasing by 1 and the y is decreasing by 6. So it's like minus 6, minus 6, minus 6, minus 6. As x increases by 1, so this is plus 1, plus 1, plus 1. As x increases by 1, y decreases by 6. So therefore the slope is going to be negative 6. Y equals negative 6x minus 4. So that's, when you find your slope, the slope is either increasing or decreasing by a certain number each time. As x increases by 1, y increases by 6 or decreases by 6. On the flip side of that, when we're talking about exponential, it's not going to be adding or subtracting, it's going to be multiplying by something. So that's why it grows faster, is because it's being multiplied each time by something. So what are the two values we need to write an equation? The a and the b. And so then we're going to write an equation, y, or f of x, equals a times b to the x. Okay. So what's the initial amount going to be based on this table of values? Well, that's usually when x is 0. So when x is 0, my initial amount is going to be 2. So that's going to be the a value. And the b value is going to be how much it is either is being multiplied by each time, right? So if you look at that, what do you think the b value would be? What did you say? 3? Oh, you're thinking 2 cubed, 8 cubed. Wait. No. I like what you're thinking, though, because you're thinking in exponents, but we're finding the base, though, right? I think is it 4? I think it's 4. Let's check if it's 4. All right. 0.25 to 0.5. I don't know. That's weird. 0.5 to 2 times 4. 2 to 8 times 4. 8 to 32 times 4. So every time you go another x, as x increases by 1, y is going to be 4 times whatever that value was. So each time it's multiplying by another 4, which is what exponents are doing, right? is when we have our base 4, that's like saying 4 to the x power is times 4 however many times. So let's just check this real quick. I got it down, but I want to make sure it's right. So let's go 2 times 4, 40. Hello, it's Monday. Monday. 2 times 4 to the 1 power. What is that? 8, right? 4 times 1, 4 to the 1 is 8, times 2 is whatever the heck I'm trying to say. 4 to the 1 is 4, 4 times 2 is 8. 2 times 4 to the second power, what's that? You have to square the 4 first, follow PEMDAS, square the 4 first, you get 16 times 2 is 32. Does that check off? Yep. Did the 8 check off? Yep. What if I put a 0 in? Does that be equal to 2? Yeah. Okay, good. There we go. All right, so that's writing it from a table. Let's do that a couple more times for practice. Here's the steps. I wrote these out. Kind of wrote it out in my own words a little bit. So how do you find the A value? That's kind of the starting value or the initial value. And that's a value for y when the exponent stuff is 0. So it's usually, you can also think of it as like, hey, at year 0. You want to check his pulse? Okay, he's good. And then to find the B or growth or decay ratio, you divide subsequent y values. So you take y2 divided by y1, the previous one, or you can take the third y divided by the second y, or the fifth y divided by the fourth y. As long as you know it's an exponential relationship, then you can take any y divided by the y before that. And that will give you that growth or decay factor. Okay? All right, let's do it. PUFTAs. Okay, so here we have growth or decay. This is decay. How do you know it's decay? Because all the y's are going down. Okay, the y's are decreasing. What's the initial amount on this one? When I get older, losing my hair, many years from now. A is not 0, dummy. I can't sing and teach at the same time, I guess. A is 64. Will you still hold me when I'm 64? You heard that song? You're leaving? All right. Run like the wind. A is 64. What about B? B is, ooh, good. B is a half. Very good. How do we get a half? You can take 4 divided by 8. You can take 8 divided by 16. You can take 16 divided by 32. You can take any y divided by the y before that. As long as you know for sure it's exponential relationship, which is what we're given. Alrighty then. Good. So now let's write our equation. We have y equals 64 times 1/2 to the x. Ka-chow. Okay, next question. We have a growth, don't we? The y's are getting bigger and bigger and bigger. So this is a growth. What's the a value? Don't know. It doesn't show us. We're going to have to work backwards on that. What's the b value? Times 3. Okay, so if I want to work backwards, then I got to divide by 3. So this is going to be a 2. Right? Question. Then, yeah, good question. You got to be careful. If this x jumps around from like 1 to 6 to 8, that's not gonna. You're not gonna be able to do that. So this only works. A strategy of like, oh, take 54 divided by 18. That only works if this is a 3 and that's a 2. If it's one more. So if it bops around and it skips, then that's not going to be true, right? Good. I like that. Good observation. I'm going to give you a high five and a sticker after this. So we have A is equal to 2, initial amount of 2. Good. So then you make your little equation there. You'd say y is equal to 2 times 3 to the x. Ka-chow! Good. Next one's the same exact type of scenario, except for when I go back to 0 for x, I'm going to get 1/5. Scary. You get start with a fraction amount. Right. So the initial amount is 1/5, and the B is going to be 5. How did I get the B to be 5? Yeah, as each one goes up, it goes times by 5. Or if I take 125 and divide it by 5, I get 5. If I take 25 divided by 5, I get 5. So it's each subsequent y is going to be 5 times the previous one. Alrighty then, so now we have y equals 1/5 times 5 to the x. Ta-da! One more word problem. I think one word problem to go. We're all over 30 minutes. This is getting crazy. Ooh, mosquito control. If the mosquito population begins with 2 bugs and triples each time, how many days, triples each day, how many days till it reaches 1,000 skeeters? Ooh, I really like this question. So the A is what? 2. The A is 2. The B is going to be triples, so that's going to be 3. It's growth. And so now we have M of X, mosquitoes in respect to X. Oh, by the way, X equals number of days. So the X value is in days, right? So M of X is equal to the initial amount, 2 mosquitoes. It triples every day, so that's 3 to the X. And now we want to solve that for when M of X equals 1,000. So we want to know, hey, when is there going to be 1,000 mosquitoes? Wow, this looks familiar. Divide both sides by 2. I want to know when 3 to some power equals 500. If only we learned about some way to solve for a variable that's an exponent. Oh, logs. Yeah, that's why we have logs. So take that and write it in log form. That's the same as saying the log of 500 base 3 equals x. Haha. If you have a fancy calculator, you can type that right in. If you don't, you can use the change of base formula and write in a log of 500 in there divided by the log of 3. And you will get like, what is it, like 5.6 days? Yeah, about 5.7 days. Doesn't take long if they triple. If mosquitoes have mosquitoes and more mosquitoes have mosquitoes and those mosquitoes have baby mosquitoes. So here's a little mosquito tip for all of you. If you have any areas in your yard where there's puddles of water, dump it out or get rid of it. Okay? If you're like me and your kids leave their toys laying around and inside the toy, like if there's an upside down frisbee and that collects water, you know what? Mosquitoes can lay eggs in that water. And then there's going to be more mosquitoes. So if you want to control the mosquitoes around your area, make sure there's no puddles of water so they can lay eggs. All right, that mosquito control tip was brought to you by... All right. Bye for now.